So this is a video to remind you of the procedure we covered in class for using Proteus. I'm going to perform a simpler exercise, but I think it will have all the needings for you to finish your task. So let me change here. Okay, so here we have Proteus. I'm going to open a new project here. Let's wait until the wizard open. Here, first we have to put a name for our project. Here I'm going to call this Blink example. Okay, and it's going to be saved in users, my username documents. You can change that if you want. I'm going to leave all the things as default. I'm going to create here a new project as it is. The schematic is going to be in default. Next, I don't want to create a PCB layout, so I'm going to leave this. And I don't want a firmware project. So here I'm going to click Finish. Now it opens this workspace. Here I'm going to put all the elements that I want in my schematic. First, clicking here in Components, I can pick a component from the list. I'm going to add an Atmega. So here I'm going to write Atmega in the search bar. Atmega. And the microcontroller for the Arduino is Atmega 328. This one. I'm going to click OK. Then I'm going to click on my workspace, and it appears the shape. I can place it wherever I want. I'm going to place it right here. And now I have my microcontroller. In order to this to work, I need to add a voltage supply. So I'm here in Components, pick a device. I'm going to write V source, voltage source, V source. And I'm going to add a voltage source. I'm going to connect this to the analog reference and also to the power pin of the Atmega. Here I have to add a ground. So here in terminals, ground, I'm going to add one there, and I'm going to connect it, clicking both nodes. This voltage, I'm going to change it to 5 volts in order to work correctly. 5 volts, okay. And I have to add a pull-down resistor here to ground. So in Components, place resistor, res. I'm going to click, I just write res, okay. And I have here my resistor. If I want to rotate that, I can click plus on the number keypad, or minus. No, it rotates in both ways. I'm going to place that vertically right here. I'm going to connect that and add a ground right there. So now I have the reset pin attached to ground, sorry. Now I have to add the crystal in order to this to oscillate at 16 megahertz. So I'm going to Components, pick device, I write crystal, and I will add this, the one that says crystal from the device library. Okay, I will rotate that, and I'm going to put it right here because we have to connect it to the extal pins. This is extal 1, extal 2. So right there, we have to add two decoupling capacitors. So I write cap in order to make that this crystal oscillate. And then I will connect this, and both of those pins to ground. Right now, ground. Okay, so this is the basic connections in order to the Atmega work as an Arduino. I will run this code. This is the Blink code from the examples. You can retrieve that in File, Examples, Basics, and Blink. Right now, I have the code right here. It's just we declare one port as an output. It's LED built-in. This is the pin 13. No? Right here, we can see the define LED built-in 13. So we have to connect an LED to the pin 13. And in the loop, I just turn on the LED, then wait sometimes 1 second, 1000 milliseconds is 1 second. Then we turn off the LED, and finally we wait 1 second. And this is going to be in a loop, so the LED will be blinking. In order to pass this code to the microcontroller, we have to click here in Sketch, export compile binary, and it will compile the code and generate some files. They will be saved in the same location as our file. So here I have to connect the LED to the pin 13. And pin 13 is in PV5. So I will add an LED here, place LED, and I have to find some LED from the active library, so we can check and modify that, so we can see when it's blinking. No? So any one of these animated LED will be okay. I will put a purple one. Okay, I will rotate that right there, so I can connect here. This is PV5, so PV5 is pin 13 on the Arduino, and I have to add a resistor. Okay, and I will change its value to 270 ohms. So right there, 270. Okay, and I have to connect this to ground. I can use this ground I got here, or I can add another one now, but I think that's correct. Okay, so I will double click on the Atmega in order to upload the code, and here in program file I can look for my file. So here in document Arduino, I will double click there. This is my file. If you see, the name is blink test from Proteus. So I open here. Then in the build file, Arduino AVR1. Okay, so this is important. When I do the export compile binary, first you have to select here your Arduino. So here I go to port Arduino AVR, and then I select Arduino. Then you can do the export compile binary. So here I got 3 files. So I will use this one, the one with the bootloader is .x. No? Then open, and I will change some things here. First, in this, the clock select fuse, I will select the, here, one with that says Excel full swing. We have 2 of them. Here, Excel full swing. Whatever is the same, I will select this one, and then I will add here the clock frequency. The default is 16 megahertz, but I will add so I don't get any troubles with that. And the other things we should leave it as it is. So right now, if I click here to run the simulation, I will see my LED that is turned on. If we wait a second, it should turn off, but it didn't. Why it didn't? Okay, right now it turned off. Then I checked already. To fix that, I forgot one configuration. Here in the clock divide, we have to leave it as unprogrammed. By default, is programmed. Now, if I make that change, here I'm going to click play to run the simulation, and now it should be turning on and off in 1 second. No? 1 second on, 1 second off, 1 second on. Okay, so now we have to generate the vector file from our diagram. So let me change here the screen. Okay, so we got our circuit here. I'm going to click File, Export Graphics, and then select the SVG file. Here we have the route in which the file will be saved. If you click here in Launch Viewer, it it will open in your default vector file editor. So here I'm not to open because I have already opened, because it takes some time to generate that. So it will generate something like this. My default viewer is Inkscape, so it opened in Inkscape. So this is our circuit. It's in the workspace, so it's in a white rectangle, in a big white rectangle. If I click here, it will select everything. If you click Ctrl U, you ungroup all the elements, so we can separate the background image. I click now the background and Supreme in order to delete it. Now, if I select all these elements, it's just the lines, no, of the diagram, of the schematic. Now I click Ctrl G in order to group all of that. Now I got a single element, and I can make Ctrl C to copy, and in Word I can click here and Ctrl V to generate our circuit. Now this is a vector file, so I can zoom in without losing any detail. No? Okay, to add the footnote of the image, let me unzoom a little bit. You can select any element in the graphic, right click, okay, it's kind of sluggish because I am recording at the same time, like I'm doing something. Right click, and now you can insert title. So here you can add your title. I'm going to add a new tag called figure. So now I have the figure tags now. Figure. Okay, so here I will add schematic blink circuit. Okay, so that's my tag. I will click here in order to center it. So now my picture have a tag, and if I want to make reference in the text for this image, let me add some random text. Okay. So now I can add here, for example, a reference to that. I will add it right there. So for that you have to go references, cross-reference, and then you have to select here your tag. I add figure to all of that, and I want to add just the tag and the number. So now I got here a tag. So this is an hyperlink. So if I make control click, it will send me to the correct picture. No? So when you have your report with a lot of pictures, you can access that. No? And then you can see with a lot of detail every element of your circuit. Yeah. So that's all. Hope you this video helps you. No?